In this video, we're going to take a look at the port Helix metering fuel system, and this is they do vary between manufacturers, but the basic principle of how they meter fuel is all the same. So this is a unit injector. Now it still has a port Helix setup in it. These have a unit injector for each of the cylinders, where when we take a look at the injection pump, where all of the metering is done within the pump itself. So how is it set up? Well, what we have inside the injection pump is we have a pumping unit. Now it consists of a barrel which is stationary, it doesn't move. We also have a plunger which moves up and down inside this barrel. It also can rotate, and this is to change the amount of fuel that's delivered per stroke. So how this basically works is, if we take a look at the barrel itself, it has an intake port and a spill port. Now, let's just say that there's 6 of them in line here. This whole gallery around this is filled with fuel, and it's under pressure of, let's just say, 15 psi. So as the plunger moves down, the plunger is controlled by a cam, pretty much the same as what we have in an engine that controls the opening and closing of the valves. So it has an inner base circle and an outer base circle. And as it rotates, it moves this plunger up and down. And that is the actual stroke. The actual stroke never changes. It always moves up and down the same distance because of the camshaft. But what we have is we have what's called an effective stroke. The effective stroke is controlled by the governor, and the governor turns the plunger, moves it so that this helix opens and closes at a different point. And we're going to take a look at a little bit later on how that works. So when the plunger is on the inner base circle, the spill port and intake port is open. Fuel can fill this void that's in here. Now, as the camshaft starts to rotate and starts to move the plunger up, the plunger cuts off the fuel. No fuel can get in and no fuel can get out. And what happens now is the fuel that's trapped here has nowhere to go. And again, as we've looked at hydraulics, what happens to that fuel? It's got to go somewhere. So where does it go? It goes out the high pressure lines and to the injector. Now, the high pressure line and the injector are always full of fuel. It's just there's very little pressure in there. So as soon as pressure starts to build here above the plunger, that force is instantly transmitted all the way through down to the injector. Now, as this plunger moves up, it injects the fuel. What happens then is once this helix uncovers the spill port, that's the end of injection. Any pressure that's up above this plunger can get down past and out this spill port. Then and this is when it's on the outer base circle, then it returns back to the inner base circle and it begins all over again. So as we see in the injection pump unit, we have a rack. And again, this rack controls all the injectors, all of the plungers together. So as one moves to deliver more fuel, so does another one. They all work together. So if we have a 4-cylinder or 6-cylinder, this rack is controlling all the plungers as a unit. If we take a closer look, we've got our camshaft, and again, our inner base circle and our outer base circle, we have a roller, and again, it moves the plunger up and down. This controls the actual stroke. The rack controls the effective stroke. Now, as it builds pressure, the first thing it does is opens up what's called a delivery valve. And a delivery valve's purpose is to maintain residual line pressure in the high pressure injection line. Now we want that so we don't get any delay in injecting the fuel into the cylinder. One thing to always remember is a thing called a retraction piston, and it's the retraction piston that makes this work. And how it works is, if you take a look, this fits inside here, and here is our delivery valve. Pressure comes in from the bottom um, as it's as pressure is created. Pressure pushes up, lifts up on the delivery valve, and opens it up and allows fuel to escape and out to the injector. Now, again, on a port and helix pump, once the helix is open to the spill port, pressure instantly drops. What happens then is we have a spring here that forces this back down. Now, if we were to rely on just this valve face to create residual line pressure, it doesn't work. It's this retraction piston as it moves down past the seat that actually causes that residual line pressure to stay at a few hundred psi. Now, if we take a look at the barrel, again, remember the barrel is fixed in position, and it's the plunger that moves up and down and can rotate with the rack. And this is the rack. And again, each injector will be set up here with the same sleeve, and they're adjustable, and they're adjusted at a fuel shop so that they all pump the same amount of fuel per stroke. Taking a look at how port and helix system is set up. So this is the helix. This is a lower helix. And it also has a spill port for when we go into no fuel position. So at an idle, the effective stroke is here. When we're at full RPM, the effective stroke is here. Again, remember, the actual stroke of the plunger never changes because it's controlled by the cam, but the effective stroke is changed by the control rack from the governor. Now, different manufacturers use different helix setups. So we have a lower helix, we have an upper helix, and we have a combination of both. So this is another picture of how it's set up. We see our delivery valve up in here with our retraction piston. And again, our spill port is open. As the plunger starts to move up, what's going to happen is it's going to trap the fuel. As it traps the fuel, that is what we consider the beginning of injection. And we're going to go in later on and take a look at how we time the fuel pump to deliver the fuel at the correct time. So we got the beginning of injection. So again, once that spill port and fill port's closed off, that is the beginning of injection. This is all trapped fuel, all in this area here. Fuel again pushes up, opens the delivery valve, the retraction piston's up above, fuel can get out and to the injector. Once the spill port is open, that's the end of injection. Delivery valve drops down, retraction piston maintains residual line pressure, and that's the end of delivery, and the plunger will now continue all the way to the bottom and open up this port and refill this amount of fuel. There is a slot that's in each of the plungers, and this is the zero fuel delivery. So the plunger can move up and down, but nothing will happen. So when we go to shut off an engine, for instance, on some of them where you have a mechanical linkage, you pull the lever out to shut the engine down, it moves the fuel rack to zero fuel. Even though the plunger is moving up and down, it never blocks off the spill port. So consequently, we can never pressurize any fuel be delivered. And again, if you take a look at the lower helix, as soon as it blocks off the spill port, we get delivery, and as soon as it opens up on the lower helix, we end delivery. On some plungers, they'll have a starting notch or a groove, and this will delay the beginning of injection. Now remember that when an engine shut off, the fuel rack is set to full fuel. And if you take a look here, this is the full fuel position. As soon as it starts, the governor is going to cut it back and is going to rotate this plunger to the idle fuel, which is over here by this zero notch. And as we increase the RPM, it moves this plunger over to the full fuel position. This is a fuel pump test stand. Again, we want each of these plungers to inject the same amount of fuel per stroke. So what they do is they set it up on this test stand. So here's our injection pump, and they can adjust each one of these uh, plungers a little bit. So let's just say we run it for 1,000 revolutions. And what we see up here is how much fuel is delivered. And if any of them are low, then they go in and they adjust them till the fuel delivery is the same for all of them. That way we're not overloading one cylinder compared to another cylinder with the amount of fuel that's injected. Now, when it comes time to timing these, again, it's like timing a distributor on a gas engine. We have to time the fuel pump. And how do we know? Well, on the fuel injection pump itself, there's going to be a tag. And so what we're going to do is on the flywheel or on the front um, balancer, there will be timing marks. And we're going to set it up. And we're going to again take a look at how fuel timing is done. It's called spill timing. On others, they'll have marks on the injection pump. So you have to find out how these pumps are set up for timing. Some, the marks are lined up and the pump is installed. Others, we have to install them and then adjust them. Some are pinned. So we can pin the flywheel, pin the pump, pull the pump off, do what we have to do to it, repin it, put it back in, and it's back in where it's supposed to be timed. So how do we know what the timing marks are? Well, again, if we take a look at this one here, this is a Mac. So it's timed at 22 degrees before top dead center at port closing. Now, if you remember from a lower Helix, we have a constant beginning and variable ending because we can vary when the plunger is turned. But because the top is perfectly flat, it's as soon as that crosses the spill port and the fill port, that's the beginning of injection. So it's always beginning at exactly the same point. Now, what happens if you get a pump that's got port opening? Well, then we got an upper helix, which means we have a variable beginning, constant ending. So you have to take a look at how the pump is set up, and they can be an upper or lower helix or a combination of both. So you have to make sure you time it properly or the engine won't run. So again, if we take a look, this is a lower helix. So we have constant beginning, variable ending, depending on where this is in relation. If we have an upper helix, we have a variable beginning, but a constant ending. And then we have upper and lower helix, which is a variable beginning, variable ending. Taking another look at how the delivery valve is set. Again, here's our valve seat, our valve face. This is our retraction piston. As pressure builds up, opens up this retraction piston goes past this opening, fuel can go through. As soon as delivery stops, this delivery valve drops back down. As soon as this retraction piston crosses this point, it doesn't allow any more fuel to come through here, and the valve face seats to make sure that nothing leaks past. But it's the retraction piston that does all the work. Different retraction pistons have different delivery valves have different size retraction pistons. Again, it all depends on what the manufacturer wants. So what about static timing an engine? Well, if we're dealing with a gas engine, we use a timing light. And we can use a high pressure timing light. We hook this up to number 1 injector line. or again, whatever the manufacturer wants. So depending on the engine, in most cases, let's take a look at an inline six, number one's at the front, but there are some instances where number one's at the back. So again, you have to read what the manual says. Where is number one cylinder? And how do we time it? Do we time it with number six or do we time it number one? So again, what we're going to do is we're going to static time the fuel pump. And then we're going to test it to make sure we've done it right. And if we haven't, we have to go back and adjust it. So what we're going to do is there's two ways to do it. We can high pressure fuel time it if you have the equipment, because again, you remember you have to be able to overcome that delivery valve pressure. And if you can't, then we have to take the delivery valve out. Now we're going to time this at port closing. So again, as soon as the piston comes up and blocks off the ports, that's the beginning of ejection. And what we're looking for is we're looking for one drop every 3 seconds. So we have a test line or a jumper line. So we're going to install the pump. First thing we're going to do is we're going to put the engine at let's say 22 degrees before top dead center, whatever the timing mark says on the injection pump. Then we're going to install the pump on the engine. We're going to remove the delivery valve. We're going to install the jumper line. We're going to take off the fuel return line off the injection pump itself and block it off so no fuel can return. And we're going to pressure up the fuel gallery that's in the injection pump. Now, when the plunger is below these spill ports, fuel is going to always come out. And then what we're going to do is slowly rotate the injection pump itself. Now, on some of the engines, there's a front cover on the very front of the engine that you can remove. And we can turn the injection pump without turning the gear train, because again, we don't want to change where our timing marks are. So we're going to put a wrench or a socket on the injection pump, and we're going to very slowly turn it until we get our one drop every 3 seconds. Then we're going to tighten the bolt that holds the pump to the gear, and that locks that in position. So here we're removing this top nut. So we've taken our jumper line off. We've moved it out of the way. We've taken our cap off. We've removed our delivery valve and our spring, and we're going to put this back in place. Then we're going to hook up our jumper line to it. And again, we're going to take our return line off and cap it because we want to be able to, with a hand primer, we want to be able to pressure up this fuel gallery. In this case, we're using a high pressure pump, but not a lot of shops have these. So if we're using a hand primer, again with the delivery valve removed, as we pressure it up, it's going to spray out. As we start to turn our pump, again, we're going to turn the camshaft on our pump in direction of rotation very slowly until we get our one drop every 3 seconds. Once we get that, we're going to tighten down the bolts that are on the gear to the camshaft. Then we're going to put everything back in place. We're going to take our jumper line off. We're going to put our delivery valve on. We're going to put our fuel line back on. We're going to remove our block from our return line and hook that back up. And then we can go back and we can start our engine. And what we want to do on our engine, we do what's called the snap test. We let it idle. Again, we want to make sure we warm the engine up properly. Then we're just going to snap the throttle. If it picks up instantly, we know we have our timing set perfectly. But if there's a very slight delay, we might be off a degree or two. And we want to go back and we want to reset that till we get it perfect. So when we do our snap test, the RPM instantly picks up. And we'll be doing this in the shop on an engine. Now, what about timing? Again, if we remember back on why do we want to advance timing on an engine? Well, we want to advance it because fuel burns at a constant rate. And the faster we are, the slower or the less time we have to burn that fuel. So we want to advance it so it always finishes burning at the same time. So there's a bunch of different ways that they go and they can advance an engine. So the injection starts earlier. So they can use, again, flyweights. and this will advance the timing. Mac used to use on their Bosch pumps, they used to use oil pressure to use a spiral that would advance the timing. Now, we've already talked about aneroids and puff limiters and how they work. So again, what do? They prevent fuel delivery until boost pressure comes up. And again, depending on how the manufacturer makes them, what they're called, but they all do the same thing, is they prevent rack travel on acceleration until the boost pressure comes up. So if we take a look at a very basic aneroid system, again, we've already looked at this, but this is how it's set up. So comes off manifold pressure, and as boost pressure comes up, it pushes this diaphragm, which pushes this control rod. This is our fuel rack. And so as boost pressure comes up, it moves this over against the stop and allows for rack travel. So CAT calls theirs a fuel ratio control valve. Mac again calls theirs a puff limiter or an AFC, air fuel control valve. So again, there's a lot of different names, but again, like I said, they all still do the same thing. Now, if we were talking about unit injectors, so this is how CAT used to have a unit injector, and so did Detroit. So what they had is they had jumper lines that went into the injector. So these were low pressure, so 40, 50 psi maybe. And it was this unit here that created the high pressure for injection. So we had a cam lobe that had another push rod that pushed this up and down, and this created the high pressure in the nozzle. But we still had a port and helix plunger in here. This injector rack, again, which were controlled, that were hooked up to all the other unit injectors in line, controlled our gear that controlled our plunger, how our plunger rotated to change the amount of fuel that's delivered. So if you take a look at this, as we move this in and out, it rotates this gear, which changes our plunger position. Now, again, on this type of system, our actual stroke is still controlled by the engine camshaft, but our effective stroke now is controlled by this rod here. And this is where when we go in and we balance all of our injectors together so they all deliver the same amount of fuel. Again, Detroit uses a gear pump. And remember, anytime we have a gear pump, we have to have a relief valve. Number one thing, anytime we have a fuel problem, is always check fuel pressure. If we don't have fuel pressure, we're not going to be able to get fuel in there for injection. It might work at an idle, but once we get into a higher idle, it may not have enough fuel to carry this on. And that is the end of port and helix fuel systems.